and, and ask why almost all of the sites were in the northern hemisphere. And when I looked on your website and the map there of anthropogenically influenced hypoxia, 19 out of 20 were in the northern hemisphere and one was in Australia. Mm-hmm. It may be a naive question on my part, but why this distribution is overwhelmingly a northern hemisphere phenomenon? That's the first question. Okay. The second question is, what don't we know about Gulf hypoxia that we need to know for the sake of mitigation and adaptation in the face of climate change? That is to say, what are the areas of research that we now must attend to in the face of climate change?
Okay. The map on the website is probably dated and is not as recent as the one I showed. Got to go talk to my technician about that. It's that slide I showed where most of the symptoms of eutrophication occurred between the 1960s and the 1980s in developed countries, which most of them are in the Northern Hemisphere, in North America and in Europe. And now you see many more of those dots off of Asia and South America. I gave a talk in Argentina once near the delta, the outflow of the Paraná River, and this was 1989, I think, and they said, well, our rivers are too large to ever have problems like that. And if the Mississippi is not a large river, I'm not really sure what a large river is, and now that estuary, that coastal zone, does have low oxygen off of it because there's more mechanized farming and more applications of fertilizer. The same thing off of the Changjiang in China, the Yangtze River, more and more nitrogen and phosphorus flux, more atmospheric deposition, huge air pollution problem there. And now many more harmful algal blooms, red tides, and the developing of what will probably be the world's next second largest area of low oxygen. So it's just shifting as economic development and our life patterns and our ways of doing things are shifting to other areas of the world. Now, as far as necessary research, I just hope I live long enough to do all the kinds of research I want to do. But one of the issues now is, it's not really, well, it's an issue. It's, which nutrient is the most important to try to limit? Is it nitrogen or phosphorus? And it's both of them, but it's in different places at different times of year, and the management techniques are going to be different for the two types of nutrients. What necessarily you do for phosphorus isn't going to help nitrogen and vice versa, although some activities will help both of them. The processing of nutrients from the Mississippi River Delta versus the Atchafalaya are very different, and the receiving ecosystems are very different. And so there's a perfect comparative ecosystem study waiting to be funded. Unfortunately, my proposals have not gotten past NSF yet. So there's a lot of work to do on that. And another issue in coastal Louisiana, which is just how to use the water for coastal restoration in trying to build land and bring nutrients to dying marshes and things like that. So what we're finding out now is that moving the water somewhere else is not the solution to hypoxia, and putting it through the marshes is not the solution to hypoxia, and putting it down the Atchafalaya Delta is going to just make more hypoxia to the west. So the solution to pollution there is not redistribution. It's to still deal with it up in the watershed. But there's a lot of things going on with freshwater diversions that we don't know the full story of yet. And we do know we're getting more cyanobacterial blooms and toxins in some of our receiving waters now from the Mississippi. So we want to clean it up before we start using it.
David Sedlak.
Nancy, you gave a very nice talk introducing the topic of hypoxia and talking about some of the causes, but I don't think you had enough time to tell us about the cures. One obvious cure would be to cut down on the amount of nitrogen and phosphorus used in agriculture.
Right.
Could you tell us about some of the cures that might involve changing flow patterns on the Mississippi River and channelization of the river to kind of retain sediments in the watershed, or change the way the river's operated?
Right. Well, I tried to give you the scenario that we've changed the landscape so much that it's no longer a functioning landscape. And then added to that is the insult of extra nutrients. So most of the landscape changes happened before we started adding the extra nutrients. So the low-hanging fruit is the added nutrients. But the watershed itself can function more normally. Even tile drains and running the water off and collecting it in a pool of water, make an artificial wetland, try to denitrify some of that nitrogen, some of which might go to N2O, which is a greenhouse gas, but some of it will go to N2. Trying to let some of the water flow over the bottomland hardwood forests that are just, prime denitrification routes down the middle of the Mississippi River. We could do we won't do like Florida. We won't put the curves back in the Kissimmee because the Mississippi River is a major transportation highway, and we're not going to put the curves back in and let it flow more slowly. So we have to work with a landscape, bottomland hardwoods, wetlands, and things like that.
Well, Graf.
Yeah, thank you. When Larry got a chance to ask 2 questions, I thought, God, that guy is really smart.
That's why he's here.
Yeah, well, I have 2 for you as well, but they're closely related, so maybe I can squeeze that in that way. One of the things that really fascinates me about your talk is the relationship between water and sediment.
Yes.
And from the standpoint of a river scientist, of course, the water and the sediment are the 2 primary constituents of that system. I wondered if, first of all, you would care to comment on the relationship to particularly phosphorus as it's moving in that system, partly in a dissolved state and partly in a state of adsorption
Right.
on the skins of the sediment.
Right.
And my second question is, I thought your graph was very telling that it showed century-long changes in discharge and sediment loading and concentrations. The discharge of water has not changed that much over a century, at a flat line. Why is that? I thought climate was changing.
There's been, let's see, total phosphorus versus dissolved inorganic phosphorus or phosphate. The phosphate is fairly consistent, 1/3 of the total phosphorus, and so that particulate phosphorus is absorbed to the sand grains and the silts and things like that. The inorganic phosphate, when it reaches the Gulf, is taken up pretty well. First of all, it gets taken up by organisms very quickly, or it joins with colloids and falls out onto the bottom. So it's taken up pretty quickly, so that it's really nitrogen that's the limiting nutrient offshore, but phosphorus can be more limiting near the rivers and other times of the year. So when you have soil erosion, you're going to move a lot of total phosphorus and inorganic phosphorus into the waters. But one thing that's happened, I'm not sure what the Missouri River has always delivered the most sediment to the whole Mississippi River discharge. And since the 1950s, when the last dams went in on the Missouri River, the suspended sediment load of the Mississippi has decreased by 50%. So we're not actually getting as much either total phosphorus or inorganic phosphorus now, which when you're putting too much nitrogen in, you skew the nitrogen to phosphorus ratios so that phosphorus now could possibly become more limiting. But the only reason it's becoming more limiting is because there's just so much more nitrogen. If you look at ratios, there's lots of other ways to look at limitation as well. What was your second question?
The discharge of the river.
Oh, the discharge of the river. Since about the 1850s to present, if you ran a line through it, it is almost stable. Some of the changes that have happened since the 1950s, there's been about, if you look at the total increase in total nitrate load, you can explain 80% of it with just concentration, the other percentage, 20%, with increase in discharge. And most of that increase in discharge can be related to landscape changes, such as tile drains, that move much more water off more quickly than historically. There's a paper in Nature about that not too long ago.
Thank you.
Dr. Biswas.
Just a comment, not so much of a question, because with your presentations, I really don't have any questions. The comment is about the situation in the developing world.
Yes.
And The first problem is we really don't know what is the situation. The data available in the coastal areas and the inland water bodies on eutrophication or hypoxia are very little. It's not a priority item for research amongst the researchers in the developing world, or a priority policy issue for the policymakers. So that is neglected. But anecdotally, I can say with almost complete confidence, especially in the developing world, most of the inland water bodies and much of the coastal areas, eutrophication is very high. And that comes not so much from the agricultural discharges from agricultural activities, but because the sewage treatment works and the industrial treatment works are simply are not there.
Right.
As a result, the phosphate and the nitrogen components in the inland waters, the rivers, and finally to the seas are quite high. Irrespective of what the World Health Organization and the UN system says, our research indicates in Latin America, for example, about 10% of the waste load is properly treated. The rest are discharged straight into the rivers and the seas and the inland areas. And so eutrophication level, I suspect, will be quite high if people start looking into it. And the other thing is, it's not only what you discussed. One of the problems we are facing in many of the developing world is aquatic weeds and water hyacinths. And they are choking up, very similar type of effect, but choking up the highways, the navigable rivers and the canals and everything. In Egypt to Lake Victoria to many other places, the growth of aquatic weeds, for whatever reason, I honestly don't know, I'm not an expert in that area, but have been very, very significant.
Right.
And that is, when I see those places, what they were 10, 15 years ago, and now you can see the difference without doing any research.
Right, well, the vegetation obviously is responding to extra nitrogen and phosphorus as well. We had a station in the upper end of the Barataria Bay, which is between the two deltas, where the Mississippi River was being diverted, and when we first set up our oxygen meters and chlorophyll meters and everything, we could get to them very easily, and after about 6 to 8 months of discharge, we couldn't get in there anymore because it was choked with weeds. So it's definitely a stimulation by nitrogen and phosphorus. And as far as the developing countries, I'm sure I agree with you on it's just human population pressures in lots of ways, but more and more agribusiness and use of artificial fertilizers. But say the Long Island Sound has a hypoxia problem, but their solution was in wastewater treatment because there wasn't that much agricultural runoff. So depending on where you are, you have to try to make a difference the best way.
Okay, at this point, I'm going to try to combine an internet question that came in and then one from the audience. And it relates to solutions. And an audience member wondered if maybe the best solution is to suspend subsidies for ethanol production. And the other one that was coming in off the internet.
I think you can tell I'm not talking to the Farm Bureau right now.
Yeah, or they're being quiet. And then the other one off the internet, their solution was maybe we should just tax fertilizer and dedicate the money to purchasing wetlands. And there's two suggestions. What do you think of those?
I think the Farm Bill and the subsidies to agriculture is a great opportunity to make a difference in how we spend our federal dollars in either production or conservation. Most of those measures have been defeated in recent attempts to amend the Farm Bill. A lot of people are working hard to do that, but there's a strong political influence that has prevented that from happening. Farm Bill, ethanol. Corn-based ethanol is probably, from most studies, including those from the National Academy of Science, is one of the worst for water use, soil erosion, excess fertilization from nitrogen and phosphorus. Takes more water to produce it than it takes more energy to produce it than you get, and if I'm getting ethanol in my car right now, which used to get 33 miles to the gallon, I'm pretty sure it's ethanol, it's got it down to 30 miles to the gallon, so it's not beneficial in lots of ways, but there are lots of other types of biofuels that can be generated from other sorts of crops that might not be so hard on the land or hard on water use or require so much fertilizer. Was there a second part to that?
No, that.
Okay. Yeah, please, just one question at a time.
Okay, here's another solutions question. If voluntary methods of nutrient control just aren't working, what do we have to do to get effective solutions?
Well, I'm serving on my third National Research Council Committee of the National Academy of Science right now on the Mississippi River and the Clean Water Act. The first was funded by the McKnight Foundation, and we gave a shopping list about this long to EPA about what they could do with the Clean Water Act to improve the conditions of nutrients and also primarily from the viewpoint of non-point source pollution. It's a great report. It said a lot of the things I've already said, but the EPA was not the funder of that report, but they received it, and they received it very well. So they funded a second National Research Council committee of the Academies of Science to look at specifically what can be done with the Clean Water Act. What would be a first good step? And that report came out with the idea of coordinated USDA, EPA sort of projects dedicated in a watershed where you could actually change things enough to see if there's a difference in the flux of nutrients off the land and through the waterways. And that was also very well received, and as a result, I think probably of that report is when former governor of Iowa, now Secretary of the Department of Agriculture, provided $320 million over 4 years to 12 states to try to have some of these directed conservation projects. But the point of the report was missed in that was just a USDA effort, and there has to be a coordinated EPA, USDA effort on these projects, not only in designing them, but in following up to see if they are successful or not. There's a third National Research Committee, which I'm actually fortunate to be on. I've really enjoyed these things. That's now looking at more specifics of the Clean Water Act, and we're probably going to get into things like TMDLs and other nutrient criteria that under the Clean Water Act are available ways to try to reduce the amount of nutrients. And I think we might see some progress in that report, and hopefully the designee for the AA for water in EPA is one of the people who started the task force 10 years ago. It's not in EPA now, or wasn't. He might be put back in. He was a strong advocate of trying to reduce nutrients in the river and using the Clean Water Act because he's a former EPA person. So there are bright lights ahead.
Okay, just a little bit more, just one more question. Keep it a simple one. What can my 4th grade class do to help? Okay. Let me see, they're not cutting the grass, so they can't complain about the amount of fertilizer, probably. They can learn about water. They can learn about where it comes from. They can learn what makes a river. I don't know if they know what makes a river, but the ocean makes a river. And the movement of water through that hydrologic cycle and how it moves through the air and on the land and how it moves. There are these great models that are watersheds that you can put red dye for sediment and see where it goes, or you can put mud and see where it goes, or you can put green water for nutrients and see where it goes. So there's great educational tools that you can use with 4th graders to show them about water and how it moves and how it's important. I think that's a really big step. You can maybe have an experiment where they have tomato plants and they put nutrients on them, and some do better and some do better, and some might actually get burned because there's too many nutrients put on them. And you can, teach them how nutrients affect plant growth. And I think there's just all kinds of wonderful. That wasn't an easy question. Okay.